প্রত্যেককে ধন্যবাদ জানাচ্ছি। আজ আমরা ক্লাস 12 এর ফিজিক্সের কারেন্ট ইলেকট্রিসিটি চ্যাপ্টারটা পড়াশোনা করব, যেটা জয়েন্ট লেভেলের চ্যাপ্টার আছে। which one is of joint level, WB joint entrance examination, and IIT level, IIT preliminary level, which will be solved in one shot. So suggestive questions are to be answered here. My channel Bidyut Flow is running rapidly. You may subscribe if you want it. This is the problem which one is written here. 5 equal resistors. Each of resistors are connected as shown in the figure. 5 equal resistors are connected as shown in the figure. We have to find the current flowing in FC. So first we have to unfold the diagram, unfold the circuit. আমরা সার্কিটটাকে বর্তনীটাকে আমরা খুলতে চাইছি। খুলে নিয়ে আমরা এখানে হুডস্টোন ব্রিজ প্রিন্সিপাল অ্যাপ্লাই করব। খুব সিম্পল প্রবলেম আছে, কিন্তু apparently it is seen a difficult one, but let us go to our duty. This is A point, unfold here, and this is the B point. A and B unfold here. This point A, this point F, this one as this format, here also this format F. When it is unfolds, then CD comes at the middle position, and when B is unfold, then this one comes as E point, because B comes at E. So here is CE, here is a DE, and here is a CD. So here is R resistance, R resistance, R resistance, R and R. So 5 equal resistances are present here. This circuit, when AB is connected through battery, when AB is connected through battery, then it is going for Wheatstone bridge principle. Why? For Wheatstone bridge principle, we know this type of Wheatstone bridge principle. Suppose this galvanometer G, suppose this is battery B dash. So, or if this resistance is P, Q, R and X, and if there is no galvanometer current, if there is no galvanometer current, if there is current flowing through circuit and no galvanometer current, for the BD sub-circuit, then we can write P by Q equals to R by X. In another word, we can write if P by Q equals to R by X, then BD sub circuit is of currentless, is of currentless. So apply the second one. We can write here as R by R equals to also R by R equals to 1. So P by Q equals to R by R equals to 1 and R by X also equals to 1. So we can say that this sub-circuit is of currentless. So we can write this as equivalent 1. So this can be written, now it is a poisonless. Poison is out, this resistance is out, means poison is out. So we can write as here is C point, here is D point, and of no current. There is no branch, no current. So this is R, this is R, this is R, this is R. So this is in parallel connection. So we can write A so this is twice R and this is also twice R. So implies this is R because R dash equals to 1 by R dash is given by 1 by twice R plus 1 by twice R equals to 2 by twice R implies R dash equals to R. So R dash equals to R. So if there is a current, so this is twice R, this is twice R. So if there is a current I, so here is also I by 2 and here is also I by 2. So we can write I as V upon R dash equals to V upon R and I by 2 equals to V upon twice R. Here FC current, FC branch takes a current I by 2, takes a current I by 2 here. Here is a point, here is E point, here is a point, here is a E point, so here is also C point, here is also B point C. So FC branch takes a current I by 2. So I by 2, so IFC equals to this. So V by twice R. So answer is C. Same problem lying on Wheatstone bridge principle is applied for the second problem. This problem says in the given circuit এই বর্তনীর মধ্যে x এর মানটা বার করতে হবে। x is unknown। কেমন ভাবে x এর মানটা বার করতে হবে, যেখানে AB একটা পরিবাহী তার যার দৈর্ঘ্য 1 মিটার, 1 মিটার দৈর্ঘ্য বিশিষ্ট পরিবাহী তার, which one is of 1 meter length, and J is a jockey point where for this system AJ equals to 60 centimeter. The galvanometer doesn't, so when the jockey presents here, the galvanometer does not show any deflection. So applying, first we have to unfold this circuit as before. Here A is connected to positive end of battery and where B is connected to negative. So as in the figure, reduced figure. So applying Wheatstone-Bridge principle, what is Wheatstone-Bridge principle? Just let us lay down this principle as this one. Suppose A, B, C, D. Suppose this is this. So if this is P, if this is Q, if this is R and D, if this is X, then we can write P by Q equals to R by X, where G current is nil. Here also G current is nil. A is, mind it, A is connected to positive. Here A is connected to positive end. So this is P. So this is P, and this is Q. This is R and this is X. Here A is connected to 12 and X is connected to B. X is connected to B. So we can write RAJ, this divided by RJB equals to 12 upon X, implies RAJ equals to rho into 60 upon A. This divided by rho into JB. This one AB is of 1 meter length, so JB is 40 centimeters. So 40 upon A equals to 12 upon X. So implies 60 by 40 equals to 12 upon X. So implies X equal to 8. So the answer B. In a cube made of copper, at 27 degrees Celsius, the number of free electrons per unit volume is this, and the resistivity of copper at this temperature is this. What is the mean free path of the free electrons in the cube? The expression for tau. Tau is the relaxation time. What is relaxation time? The time taken for corresponding collision is called relaxation time. Time taken for corresponding collision between the electrons, among the electrons, called relaxation time. So tau equals to m upon n square rho. It is the quantity which will be established later. Now we solve the problem here. This one can be written as because answer here is 25 to 50 30, so 2.5 45599 can give you these approximates. Now V equals root over 3 kt y M, where K is the Boltzmann constant. Equals to 10 to the power 5 meter per second, because this one is of value 1, because 9 into 1.38, this divided by 9.1 equals to 1.36. So it is converted into 1 into this. So mean free path lambda equals to tau times v, drift velocity, where v is the drift velocity. So 2.5 into 10 to the power minus 14 into 10 to the power 5 meter, because meter upon second, this one is of second. So 2.5 into 10 to the power minus 9 into 10 square into 10 to the power 8 angstrom equals to 25 angstrom. So answer A. This one is the problem in the circuit shown in the figure. This circuit is shown in the figure. The equivalent resistance between A and D. We have to find the equivalent resistance between A and D. So current when passes through this and this, again goes here, this. So this portion and this portion is out of our consideration. So we can write the equivalent one for which in between the A and D, equivalent resistance will be obtained as follows. This portion and this portion is to be avoided, because the equivalent resistance between A and D current flows here, goes here, also goes here, goes here, goes here. So A to D equivalent resistance is the point to be discussed for this resistance system. Which are given here. So the equivalent resistance of this system can be written as this 5 ohm. Now split it into 10 ohm, 10 ohm, split it into 10 ohm, 10 ohm, 10 ohm. Also connected into 10 ohm, 10 ohm. This splitted again. This. So again go to here. So equivalent resistance can be written as here 20 and 20. So one RS equals RS implies RS 1 by RS equals to 1 by 20 plus 1 by 20 implies RS equals to 10. So RS equal to 10. So equivalent resistance 20 ohm. Answers given here are wrong answers given. So answer B. This problem is the 12 wires of same length. 12টা তার আছে পরিবাহী তার যাদের লম্বাটা একই আছে অর্থাৎ একই দৈর্ঘ্যের তার 12টা তার আছে তাদের রেজিস্ট্যান্স রোধ সেম আছে একই রোধ আছে এইভাবে এই বর্তনী সজ্জায় সজ্জিত আছে the 12 wires are arranged in this figure in this diagram we have to find the equivalent resistance between the two corners this and this the furthest corner of the cube we have to find the equivalent resistance between these two farthest corner of the diagram. We can apply here Kirchhoff's second law or mesh law. How? Suppose there is 3I current flows into the circuit. So this 3I current splitted into 3 equal components because the resistance are same to same. All over the system the resistance are same to same. Here is also 3 wires also of same resistance. So I. So 3I can be splitted into I and I. This I goes here splitted into I by 2. Also this one is I by 2. Here I is splitted into I by 2. Here also I by 2. This I is splitted into I by 2. Here is also I by 2. Now this I by 2 and this I by 2 mixing to get here I. This I by 2 goes here and this I by 2 pulls this I by 2 into the EF circuit so as to current as I. Here is I by 2 and here is I by 2 and here is also I by 2. So here is also gives you I. Here is I by 2, here is I by 2 gives you also I. So here is 3I plus I plus I 3I. Applying Kirchhoff's second law in the circuit A, B, G, F, J, A, B, G, F, J, A. We get what we get? We get potential drop here as I, R minus IR minus IR by because potential here is drop, so negative sign obtained. Minus IR by 2, here is I, R. And this one goes against V, so here is plus V equals to 0. From which we get V upon I equals to 5R by 2 implies V upon thrice I equals to 5R upon 6 because 5 V implies R dash equals to 5R upon 6. V is, there is a potential between A and F is V and the equivalent resistance through the circuit is R dash, say R dash. So V upon thrice I, because Ohm's law, V equals to I into R dash, we get R dash equals to V upon here thrice I thrice I. So answer is C. A ring is made of a wire. This ring is made of a wire having a resistance R is 0, having a resistance R O equals 12 ohm. Find the point A and B as shown in the figure at which a current carrying conductor should be connected so that the resistance R of the sub circuit between the 2 points is equal to 8 by 3 ohm. This one when connected as this A and B, this one as resistance and this one also resistance, which two are connected in the parallel combination by this figure equivalent this. So the equivalent resistance, this resistance is of R1 suppose and this resistance is of R2. So total resistance R1 plus R2 equals to 12 given. Again small r equals to 8 by 3 ohm equals to R1 R2 this divided by R1 plus R2 equals to implies R1 R2 equals upon 12 equals to 8 by 3 implies R1 R2 equals to 32. implies R1 equals to 32 by R2. So 32 by R2 plus R2 minus 12 equals to 0 implies 32 plus R2 square minus 12 R2 equals to 0 implies R2 square minus 12 R2 plus 32 equals to 0. R2 square minus 4 R2 minus 8 R2 plus 32 equals to 0 implies 0 implies R2 minus 4 whole into R2 minus 8 0 implies R2 equals to 4 and R2 equals to 8. If R2 equals to 4 ohm, then R1 will be equals to 32 by R2 equals to 32 by 8. If R2 equals to 4, R1 will be 4 equals to 8. But here, if this length is smaller than this length, so R1 must be less than R2. So R2 must, so this one is incorrect. So we can write R2 equals to 4, 8 unit, 8 ohm, and when R1 equals to 32 by 8 equals to 4 ohm. Now L1 into rho L1 upon A1, this divided by rho L2 upon A, rho L1 upon A, this, where R equals to rho into L upon A, where L is the length of the wire and A is the area cross section, or rho is the resistivity, we know it. So this is not for discussion. This is a joint class. This is upper class of class 12. So these are not to be explained because we know it. So we can write here also L1 upon L2 equals to 4 upon 8 equals to half. So answer will be half. So answer D. This problem, hydrogen atom problem, where electron revolves around a hydrogen atom, hydrogen nucleus, and at the nucleus there is a proton, only one proton presents for ordinary hydrogen, you know it. So in a hydrogen atom, an electron revolves around a proton in a circular orbit. If the radius of the circular orbit is this is h prime equals to h upon twice pi, where h is the Planck's constant, and the velocity of electron is this. Then the effective electric current in the circular path, electric current equals to E upon electric current equals to electric current equals to E upon T, because you know Q equals to IT from here, where T is the time period of revolution, equals to twice pi upon r upon V, twice pi r. Suppose this is R, suppose this is V, so twice pi r upon V is the T, twice pi h prime square upon m square into V equals to given as square upon h prime. So H prime upon square equals to twice pi upon m e to the power 4 H prime cubed equals to twice pi upon m e to the power 4 H prime equals H by twice pi, so 8 pi cube equals to 4 pi square. So this is equal to H cube upon 4 pi square m e to the power 4. H cube upon 4 pi square m to the power 4. This is equals to T. So electric current equals to E 4 pi square m square, this divided by H cube equals to 4 pi square m e to the power 5 upon H cube. So answer D. The figure shows a circuit in which 16 resistors 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 resistors, each resistance 5 ohm. Each and every resistor are of same value, 5 ohm. The resistors are arranged in this diagram as follows. A 24-volt battery is attached to the circuit. We have to find the current in branch AB. In this branch, we have to find the current in branch AB. So this circuit, we have to first reduce this circuit into the form, because this resistance, this resistor, this all are equally, all are tagged to a single wire. 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 So we can write that these are in the parallel connection. Here is parallel connection. How? In this way. This is the equivalent circuit shown in the figure. How? Again, I am saying these four resistance are of equal value 5 ohm. Here is also for this branch and for this branch and for also this branch. So we can write equivalent circuit again. The equivalence, this one suppose R dash, suppose R dash, 4 are of equal value 5, so resistance will be of same values. R dash. Now 1 by R dash equals to 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 implies R dash equals to 5 by 4 ohm. So equivalent resistance can be shown as 5 by 4, 5 by 4, 5 by 4, 5 by 4 ohm. Now equivalent of this 5 by 4 ohm and this one is R dash, so double dash. Now R double dash equals to these three are in series connection, so R double dash equals to 3 into 5 by 4 equals to 15 by 4 ohm. So R double dash equals to 15 by 4 ohm. Now R triple dash given as so R triple dash equals to 15 upon 16 ohm. So I current through the equivalent current through the equivalent resistance equals to 24, this divided by 15 upon 16 equals to 24 ampere. Now this I current passing through, this is I current passing through this and this I1 and this I2. So you can write I1 into I2 into 5 by 4. So I2 equals to 3I1. Now I equals to I1 plus I2 equals to I1 plus 4I1 implies I1 equals to I upon 4. equals to 128 upon 4 into 5. Now this I1 split it into 4 resistances. So each resistance covers I1 by 4 current. So I1 by 4 equals to 8 by 5 ampere. So IAV equals to I1 by 4, 8 by 5 ampere. So answer A is the right. A single battery of EMF E and internal resistance R is equivalent to the given circuit. We have to find answer from the table. Here this is positive end, this is negative end. What does it mean? There is a circuit, if there is a battery placed here, and that battery is of EMF E, which is to be found out, and internal resistance is given in the figure as shown. So applying Kirchhoff's second law or mesh law, we can write for this. This is again current flowing from this end to this, current flowing this and this end to go this to this way. So we can write for this potential drop here. So minus I R2 plus potential arises here, E2 coming here, potential arises E1 and potential drops minus I R1 equals to total system is of no battery, so 0 implies I equals to E1 plus E2 this divided by R1 plus R2 equals to 7 by 6 ampere. Now this R1 R2 are in parallel connections, equivalent R dash equals to given as R1 R2 is divided by R1 plus R2 equals to 1 into 2. This divided by 1 plus 2 equals to 2 by 3 ohm. So this one answer D is the correct one. Also E equals to here positive end, so this to be here is positive end, E1 minus IR1 equals to 2 minus so equals to 5 by 6 volt. So answer A and D is the correct one. Again I am saying for this circuit, here is positive end, so I current goes here in this way, and this one is negative end, so potential drop here minus IR2, again potential arises here, goes here, potential arises here plus, and potential drop here minus, and total circuit is of battery less, so 0. From this we can write this, and this one and this E. How E obtained? Here is plus, so here is plus. If this one is taken for A, for E voltage, then here is minus 1 is present, here is plus, so this one to be taken here for estimation. So E1 minus IR1, from this we can get E equals 5 by 6. So answer A and D. We have to find the equivalent resistance between A and B. Here statement given as any two adjacent dot, the resistance between any two adjacent dots is 1 ohm. So we can write from this dot to this dot as 1 ohm, from this dot to this dot as 1 ohm, this dot to this dot as 1 ohm, in this way. In the given figure, resistance of these are wires. So we have to find the equivalent resistance in between A and B. Suppose this one and this one to be equivalent to us. We get and this one and also this one. This 4 to be equivalent in the equivalent circuit you can write. The equivalent of this equals to the equivalent of this, because this is in parallel connection, this one also is in parallel connection. So R dash can be given as so this one equal to 2 by 3 ohm, this one also 2 by 3 ohm, this one also 2 by 3 ohm, this one also 2 by 3 ohm. Now this between A and B, resistance, equal resistance, RS plus RS we get. So R double dash, here is also R double dash, we get R double dash equals to 4 by 3 here is 2 by 3 ohm, 2 by 3, and this one is 1. So plus 1. So given resistance between A and B, so answer B. The radii of two concentric spherical cells, the radii of two concentric spherical cells are given as A and B, where B is greater than A. The region between the region between the two cells is filled with a conducting material of resistivity rho. We have to find the resistance between the two cells. We have to find the resistance between the two cells. Suppose this is a spherical cell and also this is a spherical cell. This is of radius A and this is of radius B. We have to find, here is a conducting material present. We have to find the resistance of this conducting material. Suppose there is a layer of resistance of radius x. Suppose there is a cell of radius x, and also there is a cell of radius x plus dx. This one is of x plus dx. We are going to solve the problem into the integral calculus. So, if we want to find the resistance of this infinitesimally small thick cell, we can write dr equals to rho times the length. What is the length? Length is dx, and what is the area of cross area of the cell equals to 4 pi x square, because the cell is of surface area 4 pi x square and the length, which one is dx, so rho dx upon 4 pi x square. Integrating, we can write r equals to rho upon 4 pi from A to B, x equals to from A to x equals to B dx upon x square. Integrating dx, we know integral dx upon x square. You know it at the 11th class, so it is not to be mentioned here. So equals to x to the power minus 2 plus 1, this is minus 2 plus 1 equals to x to the power minus 1 upon minus 1. So minus 1 by x, rho upon 4 pi 1 by a minus 1 by b. So this one, answer D. this one circuit A of resistance X. So this one circuit A can be reduced. A can be reduced as because this portion R here, this, if this one is taken out, so this going to for infinite position. So these R and twice are fixed here, and this portion is taken for the resistance X. So we can write implies 1 by X equals to 1 by R plus 1 by twice R plus X, because this infinite circuit, again I am saying this portion is repeating. So if we take the first this and the second to infinite number of this branch is of resistance X, should be the resistance X. So total resistance also X and this also of X. So we can write this. If minus taken, so total resistance will be negative, which one is impossible. So X equals to R times root 3 minus 1. This is circuit B. For this circuit, we can write this one, so this one. So implies y equals to twice r plus ry upon r plus y equals to if minus sign taken, so this one will be negative one. The resistance cannot be negative. So it should be written as root 3 plus 1 y equals to this and x equal to this, from which we can write xy, from which you can write number 1 y is greater than x, because y is plus, here x is minus, and number 2 xy equals to r square 3 minus 1 equals to 2r square. So this one is also right, this one is also right, and y is this also right. Okay, x minus y equals to minus minus 1 minus 3 minus plus means minus 1 equals to minus 2r. X minus y equal to, so this one is wrong. So answer A, B and C. Answer A, B and C. This one is a wrong one. Here is the problem, where two wires A and B are made of the same material and their lengths are at 0 degree Celsius respectively, this and this. The area of cross section of the two wires are respectively this and this. The temperature coefficient of resistance of the two wires. So alpha answer, alpha A. RT1 equals to R01 1 plus alpha 1T and RT2 equals R02 1 plus twice alpha 1T according to problem. Temperature coefficient of these are connected in the series combination, then R dash equals to RT1 plus RT2 equals to R01 1 plus alpha 1T plus R02 1 plus twice alpha 1T equals to R01 plus R02 plus R0 alpha 1 plus R02 alpha 1. Now R01 equals to so R is equals to RG1 plus R02 plus T times minus R equals to this one, this divided by RT. So this one cutting out, TT cutting out equals to 6 rho 0 1 L by A. So cutting out we get 6 alpha 1 by 5. So this is all about, so answer B. So this is all about today's class. If you want to subscribe my channel, then you can subscribe it. The channel's name is Bidyut Flow. Thank you.